Okay, well, this is session number 11, and we're talking about topic 18, RF and electrical safety. This is the last topic we're covering for this series for Gordon West's General Class License course. So what we're going to do is we're going to get right into it here. It shouldn't take more than about an hour to get through this. We don't have anybody live tonight, and I just want to kind of mention if there's no questions or concerns or anything that needs clarification, I probably will not be doing a recap or review online session unless specifically requested to. But I would really appreciate that if you do have those concerns, send them to me in an email. You can send it to Wayne at n3lms.net. Lima, that's November 3, Lima, Mike Sierra.net. And I'll do my very best to help you out here and try to answer whatever questions you may have. Okay, RF and electrical safety is very important. You really need to kind of pay attention to this so that when you're working with antennas and also working with maybe at least older equipment, that you do some due diligence and making sure that whatever you're doing safely, even climbing a tower, a ladder, whatever it may be. But we're going to get right into this and see what Gordon West has to say about it. Do, 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 do. Okay, if you've got your books handy, I need to pull my book out here real quick just to make sure I can reference properly what we're looking at here in this this particular topic. We're talking about precautions and anything else that needs to be a little bit of diligence and caution taken while working on. So while working on an antenna system, turn off the transmitter and disconnect the feed line. Good advice, unless somebody's going to actually push the talk to button. Um, it, you're probably not going to get any type of RF burn, even if it is connected. But it's always a good idea to turn off the transmitter and disconnect the feed line at any time that you're working on the antenna system. Um, and that way, there's no way that someone can actually transmit accidentally while you're making repairs or adjustments at the antenna site. Okay, to ensure that no one starts rotating a beam antenna using the electric powered rotator, you need to double check that the rotator control unit is unplugged and tagged climber aloft, or at least something that, to that effect that says, hey, don't touch this. I'm on the tower or whatever. Okay. And whenever you're on a tower, make sure that you have the proper safety harness and glasses, and if possible, a hard hat. And, but a full body safety harness is really a good idea to have available. And while you may not have one yourself, check around with a club member to see if someone else might have one. Stand by. My radio in the background is annoying, and I'm going to go turn it down. Okay. There we go. I don't need that background noise. Let's put it that way. You can see in the picture just kind of barely that the climber there is harnessed up, and he's rather up there at the top, and he may slip a little ways, but I'm sure he's got that clipped right to the top there while he's working on that antenna. I don't think his reach is actually that far out, and I'm for that particular type of antenna, I'm not sure what he's reaching for, but it looks like he's reaching for a rotatable beam up on top above the HF beam there. Okay, preventing falls from a tower is best achieved with a professional safety harness. So always make sure that the belt is rated for the weight of the climber and is within its service life. There is a service life. Uh, that doesn't mean they're useless, but the thing is that you really need to be careful. If you find yourself at a ham fest and you buy yourself a safety harness, be very careful when you do. You don't know how long that person has had it. If they have some specs on it, that would be great. Look at each and everything on that belt, that harness, to make sure that it is in really still very good condition. There's no fraying, there's no tears in any of the harness attachments. Make sure that it doesn't appear that anything, any of the metal hooks or rings are not missing. All that. Look, inspect the metal even. Make sure that the metal isn't cracked in some way, and that could possibly work itself loose. So check those hidden parts that might be in the loop of the harness itself. If you can, just kind of look down inside to make sure. If it's a ring, just rotate it just to make sure that the metal fasteners themselves are in good working condition. Performing a routine RF exposure evaluation is a good idea for all amateurs to ensure compliance with RF safety regulations and that your neighbors are not being overexposed to RF radiation. Seems kind of silly in a way that you do an RF evaluation, um, but you just in most cases you're not really going to need to do that. I mean, if you're running a 1.5 kilowatt station, or even a 1 kilowatt station, maybe even 600 watts. You want to make sure you're not in proximity where a neighbor or somebody can be exposed to some RF radiation, fry a brain cell or two or whatever. Um, and most of the time, your antennas are up high enough, far enough above the rooftops of most houses that it's not going to be an issue. Um, thing is, keep an eye out and keep an ear out for any indication that you might be interfering with things in not only just your house, but in your neighbors' homes as well. Some type of electronic interference. Maybe somebody's working in the microwave, and all of a sudden their microwave is kind of going nuts, and it's going nuts at about the same time that you're babbling on the air, and you're running about a kilowatt out on your antenna, and it's affecting the microwave oven. Chances are you really need to do some RF exposure evaluation. Uh, if you uh, if you do that, just refer to the Part 97 of the FCC rules, which is Part 97.13, and it shows it there on page 200. Okay. It's always a good idea to locate an antenna as far away as possible from living spaces that will be occupied when you're transmitting. So, if you're just receiving, however, that's really not a problem. But when you're transmitting, get your antenna away from everyone to minimize RF exposure. And this will help ensure that the maximum permissible exposure limits are not exceeded. And that's exactly what that RF evaluation determines, whether your maximum permissible exposure limits are exceeded or not. Some people have crank up towers, and you really, if you're running a power station, um, you want to crank that tower up, get it up above everything, and you probably pretty much assured that you're not going to fry somebody's pacemaker or their hearing aid or anything of that sort. So just be mindful about how much power you're going to be running. In most cases, you're probably just going to be running barefoot or whatever the radio actually puts out, which is typically for most of your ham radio equipment today, the barefoot uh, output power is around 100 watts. And even some rigs will run 200 watts. And those generally aren't any real problem anyway. So be mindful of those things around you, even when you're operating at that power level, to make sure you're not affecting somebody's insulin pump or their pacemaker, their hearing aid, or whatever. Mm. If RF energy from your antenna system is concentrated on the human body, it will heat the body tissue. It's not just microwave ovens, but it can be any RF energy if it's powerful enough. And they are very real things. RF burns can occur even at the lower frequencies known as HF or high frequency. Um, that can also be done from can occur uh, when there's poor grounding involved of the equipment. That's why it's really important too to make sure that you have a proper grounding system. We covered that back a few topics ago, and running that strap um, to all of your equipment to a point, a central connection point inside, and then running that outside to a ground rod into the ground. That helps eliminate any stray static electricity or RF, stray RF, maybe on the outside of the cabinet. Particularly really important with older type equipment, but it should be done to all your equipment to make sure that it's well grounded and that you're going to minimize causing issues and RF burns and things like that. I know that um, when I first got started and I had my Helicrafters HT40 transmitter operating, and it was only a 75-watt tube rig, and I used CW since I was a novice at the time. I noticed one day I kinda touched the cabinet, and I got a slight shock or a slight burn, just from that momentary touch, and it was because that radio itself, did not have a built-in ground wire for the power itself, and also it didn't ground properly the antenna, the shielding of the antenna. So I had to run a ground wire to that radio, and that eliminated my problem. I didn't get RF shocks. I didn't get stray electrical current on the outside of that cabinet or any of that other stuff. So that can be very important to make sure that you're well grounded to prevent any problems that may occur. Okay, you can determine how your station complies with the FCC RF exposure regulations by using the W5YI RF safety tables, which are in the appendix of this book. And they can be used to estimate safe distances. And that's all based on the FCC OET Bulletin number 65. If you want to look there real quick into the back where the appendix is, I don't if I can find it myself here. Okay, there's a lot of stuff in the back here in the appendix that can be worthwhile looking at and give you an idea. It's all part of that after getting licensed learning, but it's a good idea to even know it before you even get a license, so you know what to expect. Um, it's in here somewhere. I haven't been able to find it yet. Have a glossary of terms and some other stuff. But at any rate, check that out. And at any rate, these distances can also be determined using your own calculations based on computer modeling. The alternate thing you can actually do is go out there and measure the power density levels with a field strength meter. And that just means having somebody inside to actually push the transmit key while you have a little RF field strength meter, and you can walk around and you can see what the RF field strength is while you're transmitting in different locations. You'll also be able to see what your radiation pattern is kind of like and get a little bit of a model of your radiation pattern off of your antenna, be it a wire antenna, a vertical beam antenna, whatever it is. It'll give you a good indication of what your RF pattern is, as well as how much RF exposure you're getting based on the reading through the signal strength meter. Time averaging is a method of calculating an individual's total exposure to RF radiation over a given period of time. Uh, Time averaging. The premise of time averaging is that a human body can tolerate large amounts of RF radiation if the exposure is received in short bursts, as compared to a constant exposure at the same high level of RF radiation. You know, when you go in and get an X ray, you're actually being exposed to RF radiation, but that is a very quick burst of energy that passes through your body. And in most cases, it's harmless. If you're getting X-rays done every every few months, you might have a little bit of concern there because that effect can almost be cumulative in your body as far as those RF energy bursts are concerned. And of course, those are high enough up in frequency uh, significantly that um, it can be a little bit more of a concern than even HF. For the most part, when you key down in your shack, you're not really exposed to a whole lot of RF in the shack. You can take a signal strength meter and set it there on the desk right next to your body. And when you key down and look to see if there's any spurious radiation, just happens to come out through the shield of your coax. About that time is probably when your coax shielding might be breaking down and you might need to replace some coaxial cable, the jumpers, or whatever you have in there to see if you can minimize or eliminate any type of RF exposure at all. So, as you're looking at this question in the book, however, what is it, um, A04? That is on page 202. And you have a little chart there that kind of gives you some information about exposure times and things of that sort. So, as depicted, though, the total exposure to various levels of radiation is averaged over a 6-minute period. On a time averaged basis, the amount of thermal load on the body is equal in all cases. We talked about duty cycle before with your transmitter about being on and off. It is the percentage of time the transmitter is actually sending out energy. And if you hold down your telegraph key for a continuous full transmit power output, the equipment would essentially be operating at 100% duty cycle. If the space in between each dit were equal to the duration of the transmitted signal, the equipment would be operating at 50% duty cycle. So what happens is that when you're operating Morse code, and what it's saying here is that when you key down and you go through the various motions to formulate the dits and das that form the characters and words and sentences and things like that, there is a duty cycle. When you key down, transmit or transmit. When you release it, when you release the key, the transmitter is not transmitting. So that is your duty cycle. Uh, in essence, though, the lower the duty cycle is, it permits greater short-term exposure levels to RF radiation. So there you go. The lower duty cycle permits greater short-term exposure levels to RF radiation. That's kind of an odd way to say you're less exposed. The lower the duty cycle, you're less exposed. So there you go. There is a lot to do before you can consider your station safe and be sure you are not exceeding the maximum permissible exposure limits. And in this particular question of AO2, you see a bunch of options there listed: duty cycle, frequency, power density, all those steps or answers are correct. Referring back to section 97.13 of the FCC Part 97 rules, it states that if your station's RF exceeds permissible limits, you must take action to prevent human exposure to such RF electromagnetic fields. And that's why it can be important in some cases to actually do an RF measurement, exposure measurement. So if your station does exceed those permissible limits, you need to solve that problem, plain and simple. Although a simple field strength meter can show the presence of radio frequency emissions, it takes a precisely calibrated field strength meter with a calibrated antenna to really make accurate measurements of the RF field. There are some, if you remember, if you remember any time and were active in the CB days, the CB craze days, you could go out to Radio Shack and you could buy yourself this little tiny box called an SWR meter that you would plug in a cable on one end that leads from your radio, and the cable on the other end would lead to the antenna. And then you could key up and you could look at the little meter and do whatever calibration you needed to determine whether your antenna was had a nice little SWR that made the radio fat and happy. But on those little tiny boxes, there was also what came with it was a little antenna, and you could take and screw that little antenna in. And once you disconnected it from the radio and hook the radio back up, and you could walk around and see what your RF exposure was by looking at how much strength was on the meter. It had a separate scale for that, and and determine how much radiated power. And you could actually, like I said before, determine your radiation pattern. But that is not a very accurate one. A good calibrated field strength meter with a calibrated antenna would be necessary to do really accurate measurements. There are all sorts of great 5 band and 7 band trap vertical antennas that work very nicely mounted on the ground or on a metal shed just above the ground. I've mentioned before that I have a Hustler 5 band trap vertical. It covers 10, 15, 20, 40, and 80. And some of these verticals now are 7 bands to cover the 12 and 30 meter bands. So you can get those as well. And generally speaking, you really need ground radials for those types of verticals to give you a good ground plane or a counterpoise to get the proper not only the proper impedance matching, but to give you the maximum usable frequency going out. So, but you really need to make sure that when you install it, you do so that no one can actually walk up to it or stand near it when you're transmitting. And this also goes for your pets. You know, you don't want to fry Fido or your little full fur ball by leaving a ground mounted vertical antenna unfenced. So if you have an antenna, a vertical antenna sitting in your backyard, do make sure that if the kids are out playing, if the dog is out playing or anything else, humans out there barbecuing or whatever, and you decide to get on the air, if they're in proximity of that vertical, it could cause some issues as far as RF exposure is concerned. So you want to make sure that people stay away from that as far as possible if you're operating. If your calculations indicate that you may be exposing your neighbors to too much RF, you need to relocate your entire antenna system or take precautions to ensure it cannot be pointed in their direction when transmitting. Um, let's say you've got a beam antenna. To do a good RF measurement, you want to, of course, use a good RF signal strength meter. Uh, rotate your beam antenna in the direction of your neighbor. And of course, you want to get your neighbor's permission. You want to work with your neighbor with this. Stand against their house. And even though the antenna is up above the roof line, stand against their house or maybe even just inside a doorway where typically you're near where your antenna is, or at least in line of sight of your antenna. Have somebody key down and take an RF measurement. See if you pick up anything. If you do, there may be cause for concern. Um, if you don't, then there's not really too much cause for concern. But you just want to make sure that you're not exposing your neighbors to this. And typically, when you're broadcasting using a beam, it's uh, it's a compressed signal in as far as directivity is concerned, and you're not really causing any issues. But you never know, so take that precaution if you can. The National Electrical Code does cover electrical safety standards as they relate to your conductors and any wiring inside your ham shack. RF exposure limits to the human body are covered by ANSI, not by the NEC. So you want to make sure that the National Electric Code, the ANSI proper safety there, covers electrical safety standards. ANSI covers the RF exposure limits. Your ground fault circuit interrupters are found in some of the newer electrical plug outlets, and they will instantly open a circuit to halt current flow when they detect current flowing from the hot wire to ground. So there's a picture of a ground fault receptacle, and chances are you probably have them in your bathroom and in your kitchen, and actually anywhere, maybe in the laundry room, and anywhere that there's a potential of touching the um, some kind of an electrical appliance plugged into it, and you got water running and everything, and all of a sudden you get a shock. And well, these are designed to trip the circuit so that you don't fry yourself. Good station grounding ensures that no hazardous or dangerous voltages appear on the metal chassis of your equipment. So, without good grounding, you could be shocked when you touch a piece of equipment. I mentioned that earlier with my older equipment. So, you want to make sure that you do have good station grounding to prevent and eliminate hazardous and dangerous voltages on the chassis of your equipment. Most ham transceivers run on 12 volts DC. Some of them may have their own 110 volt AC power supplies built in. However, linear amplifiers may require 240 volts. For single phase 240-volt AC hot fuse both the black and red hot wires. You never fuse the neutral white wire or the neutral ground bare copper wire, but most amplifiers already have their fuses circuits built in. So generally speaking, if you have a amplifier that is rated for a certain output wattage, it may require a 240 circuit, much like your electric dryer might require. Um, for mine, for instance, my AL811, a Meritron, is 600 watts, and it operates just fine on 110 volts AC. So I don't need to put in a 240 AC circuit just for my amplifier. So take that in consideration when you're out looking for amplifiers. Does it require 110 volts or does it require 240 volts? And to make sure that you do everything safely, you want to make sure that both the black and red hot wires are fused in that case. Based on the American wire gauge, AWG information shown, the 14 gauge wire does handle about 15 amps. And the easy way to remember this is with the F for 14 gauge wiring will handle 15 amps. And you have a little chart there that shows um, how many continuous duty current amps those will handle. 14 gauge wire handles 15 amps. The more amperage you handle or want to handle, the bigger gauge wire you need to use. So, according to the chart, 20 amps of continuous current requires a wire size of number 12. And the easy way to remember this is with the T for 20 amps current requires AWG number 12, T for 12, T for 20, T for 12. So don't confuse the T for 20 and the answers. Current flow and wire size don't match like that. Thick or thin insulation can be misleading about the actual wire size. So you need to strip off the insulation and from the unmarked wire to determine which gauge wire you are working with. There are gauges available that have little holes in them at the electrical industry. People in the electrical business have usually handy with them. I have one here. If I want to know what the gauge wire is and I'm not real sure, you know, after a while you can pretty much tell what gauge it is. But if I really want to be accurate and want to know for sure, I'll take this little gauge and I'll slip the wire and find out where it actually, which hole it actually fits into. And I'll look at that hole to see how it's marked and it'll tell me what gauge wire I just slipped into it. Linear amplifiers generally use vacuum tubes and will likely have a power supply interlock switch. What this means, if the equipment is on and the power supply door is opened, the equipment will either instantly power off or you'll hear a loud bang when the high voltage gets shorted to ground, tripping an internal fuse or breaker. But this protects you and the equipment from high voltage shock. Um, and that's generally correct. If you have the cover off or the door open to a linear amplifier, generally speaking, it has an interlock switch that will cut the power uh, so that you don't inadvertently shock yourself or blow up the equipment or whatever. Anytime you're working on radio equipment innards, I love that word, the inside of the equipment. Wash your hands when you finish to remove any lead that might be contained in that roll of old solder before you grab a sandwich. And what they're talking about here is you've opened up your radio, you've done some soldering, you've made some repairs, and solder generally is kind of lead based, and you might have some contamination, so you don't want to contaminate your body with that. Just wash your hands when you're finished. That's a good rule for anything, mowing the grass, scratching your butt, whatever. Wash your hands, and that way um, you're not going to spread germs or other toxic matter onto whatever you're eating and consuming. A good engineering practice for a lightning ground indicates that all grounds be bonded together with all other grounds. That's a good engineering practice. Just kind of remember that. All grounds be bonded together with all other grounds. Good engineering practice. Carefully inspect tower grounding circuits, and you will find that all the ground connections have been swagged rather than soldered, or swaged rather than soldered. Soldered might melt on a direct lightning strike, destroying the route to ground. So that's where you need to really just kind of look and see how the ground connections on your tower might be connected. The running generator exhaust contains carbon monoxide, and that can certainly accumulate inside a closed space. And of course, carbon monoxide is lethal. So think about fresh air safety when operating a generator. A field day will be coming up next month in June. Typically speaking, those generators will start humming and buzzing right around noontime. or 10, 11 o'clock in the morning or whatever. They're generally placed a little bit out of the way because normally they're noisy anyway. So you really want to kind of have those a little bit out of the way, maybe some kind of a noise blocking barrier or whatever. And that way you're really assured that you're you're not going to be exposed to the exhaust of it. Good idea that when you approach it, you probably might want to shut it off before fueling. That's another safety precaution anyway. And because you really don't want to be trying to fuel it while it's running. And also, while it's running, you could be breathing in carbon monoxide. So think safety when working with a generator. In an emergency, when you look around and see nothing but down power poles and know it's going to be several days or weeks before electricity is restored, you might want to power your house with a generator. And you might have an RV. I don't know. I have a separate generator. It's 5 kilowatts. And all I do is I'll pull that out of the garage. I'll start it up and I'll hook it up to the RV input, the RV electrical connection on the outside of my garage, backfeed the electric back into the sub panel, which also runs underground to the house since my garage is detached. But before I do that, before I actually hook it up, I go and I turn the main breaker off in the house. That way, I'm not backfeeding into the electrical grid and trying to power other people's homes as well. And I can simply, let the generator run. And looking around outside periodically, I can tell when the power has been restored, and then I can go down and shut the generator off. But anytime you connect that generator into your home, you must absolutely trip all of the breakers to disconnect the incoming utility power feed. And like I said, this is to make sure you're not sending voltage back into the grid. And that can really prove dangerous as well to people working on the lines. So make sure you turn off your main breaker at your main panel where your power comes into your home before you turn on or connect up that generator. And anytime you use a generator for power, make sure the generator is located in a well ventilated area. Like I said, mine's outside. I'm not typically around it. I need to go out, shut it off to fuel it up every once in a while, but it's still very well ventilated. So it rolls around on wheels and works quite well. The generator should also be properly grounded and always store the generator's fuel in a safe place away from the inhabited area. Well, that concludes that. We're going to get into the Q&A here real quick. Okay. Get my lips moistened once again. So here we go. What precautions should you take whenever you make adjustments or repairs to an antenna? Again, we don't want to be accidentally transmitted on, so you want to make sure that you turn off the transmitter and disconnect the feed line. So B is the answer here. What should be done by any person preparing to climb a tower that supports electrically powered devices? You don't have to let the electric company know, so you forget that. Okay. It's automatically a dumb answer. Unground the base of the tower. That's a dumb answer too. Actually, B is your correct answer here. You just want to make sure all circuits that supply power to the tower are locked out and tagged. That's power to the rotator, feed lines to the antenna, any lighting you may have on the tower, things of that sort. Hmm. Which of these choices should be observed when climbing a tower using a safety belt or a harness? Okay. Um, when I look at A, never lean back and rely on the belt alone to support your weight. Why the heck else do you have that belt? if you can't rely on the belt to safely keep you on that tower, you've got the wrong belt on, let's put it that way. You got the wrong harness on. A is a stupid answer. It may sound right, but man, if you were to slip, that harness, that belt better support your weight for ever how long it takes for you to regain your footing or for somebody to help you. Um, in essence, the correct answer for this is B. You need to confirm that the belt is rated for the weight of the climber and that it is within its allowable service life. Very important. Rated for the weight of the climber, that it's within its allowable service life. Which of the following steps must an amateur operator take to ensure compliance with RF safety regulations when transmitter power exceeds levels specific in Part 97.13? And it's a very simple answer is that you're going to have to perform a routine RF exposure evaluation. What precaution should you take if you install an indoor transmitting antenna? You want to make sure that the MPE limits are not exceeded in those occupied areas. Now, I run a VHF, UHF small mag mount antenna inside my house when I'm not down in the shack. I have a radio up in my kitchen, and from there, it I have a coax that runs up to a little stand up in the walk area above the in the loft, and it sits there. A little mag mount antenna sits on top of a metal plate, and it's away from me. It's not near me. It's up high because when I'm using it, I'm usually down in the kitchen, and the antenna's up on the second floor. I also use that when there's storms and I have to disconnect my outside antennas. Some hams will actually install antennas inside their attics so that they can continue to operate even if there is a storm going on or even if their antennas get knocked down during a storm. And it's very easy to put in a trapped dipole in your attic if you have, fairly decent length of attic. Put yourself a HF dipole up there. You can use an antenna tuner for that. You can put yourself a nice little vertical antenna for VHF and UHF operation. And it's generally out of the way that you're not going to expose anybody to anything. And just some suggestions if you want to continue to operate during adverse conditions, adverse weather conditions. But make sure your MPE limits are not exceeded in the occupied areas. That's very easy to do again with a little signal meter, a little portable signal meter. You can tell, how much radiated power is coming out. And believe it or not, you can still work the world from an attic mounted antenna. So there you go. You may not have the best signal in the world, but you can still do it. So, what is one way that RF energy can affect human body tissue? And one thing, I mean, you just think about microwaves. What does a microwave do? Microwave actually heats your food. It produces a reaction inside whatever you're heating up that causes it to heat up. So what it really does is it will heat your body tissue. So you got to remember that RF energy will heat body tissue, whether it's microwave, HF, VHF, or whatever. How can you determine that your station complies with FCC RF exposure regulations? Let me just kind of back up here real quick before I actually get into that. When talking about RF energy, uh, if you have a cell phone is a good example of RF energy. People don't realize this. They have a cell phone up to their ear. Um, there's actual RF energy that cell phone is transmitting. It's not, granted, it's not very much, but so many people, this is what concerns me. So many people have these things up by their side of their head almost endlessly that some people will actually develop tumors or RF burns because of it. And sometimes, if I know that in my case, if I'm using my telephone, my little smartphone, it can get rather warm while it's actually being used. And I try to use mine on speakerphone as often as I can. I don't bring it up to my head, um, but unless I absolutely necessary. But try to use the speakerphone as much as possible. But you can get an RF burn. You can get some significant damage to your tissue uh, from that exposure of that cell phone. If you don't use it very often, it's nothing to be concerned about. But I tell you, some people, I think they have it, they may as well just have it glued to their heads. They're on it so much. And I just don't understand that personally. So, how can you determine that your station complies with the RF exposure regulations? And you can do the calculation based on the OET Bulletin number 65 that was mentioned. You can also do that based on computer modeling and by measurement of a good calibrated field strength meter um, and a good calibrated antenna. So, all of these choices are really correct. What does time averaging mean in reference to RF radiation exposure? And that's when your total RF exposure is averaged over a certain time. Has to do with the duty cycle of how much time or how long RF is actually transmitted versus the time that it's off. So, time averaging is the total RF exposure averaged over a certain time. What effect does transmitter duty cycle have when evaluating RF exposure? So, again, the lower the transmitter duty cycle permits greater short term exposure levels. That's just a way of saying that the lower your transmit duty cycle, um, the less exposure you're going to get. Which of the following properties is important in estimating whether an RF signal exceeds the maximum permissible exposure, or the MPE? The following properties that are important in estimating that. Well, again, you have your duty cycle, you have your frequency, and your power density. So all of these choices are correct. Okay, what must you do if an evaluation of your station shows RF energy radiated from your station exceeds permissible limits? Pretty simple here. You need to take action to prevent the exposure to humans have excessive RF fields. Be sure to do that. And what type of instrument can be used to accurately measure an RF field? Again, we're talking about that field strength meter, and it should be properly calibrated and used with a properly calibrated antenna. What precautions should be taken when installing a ground mounted antenna? Where I was telling you, this is a vertical antenna, it's right at the ground, and it's accessible to being touched by any animal. It could be a pet, could be, it could also be a kid or any other human. So you want to take some precaution to install it to make sure that it's not easily accessible and protected from unauthorized access. Man, I tell you, I got a little bit of I'm on the verge of hiccups here, but got a little bit of gas going on. So I apologize for my halting talking here. All right. What is one thing that can be done if evaluation shows that a neighbor might receive more than the allowable limit of RF exposure from the main lobe of a directional antenna? Well, very simple. I mean, if that antenna is pointing in their direction and they're getting some RF exposure, you want to take precautions to ensure that the antenna cannot be pointed in their direction. So you may not be talking if your neighbor there on your southwest corner of your lot um, is getting some RF exposure, anything you're looking to talk with on the southwest corner, um, you might have to forego for the time being until your neighbor goes away on vacation or goes out shopping. So, which of the following is covered by the National Electrical Code or the NEC? Uh, Really, the only thing that is covered in the electrical code is just what it says there, and that's the electrical safety inside the ham shack. So, really, the answer is right there in the question. The electrical code covers electrical safety. And which of the following conditions will cause a ground fault circuit interrupter to disconnect the 120 or 240 volt AC line power to a device? And remember, this is flowing from, it's going to be current flowing from the hot wire directly to the ground. B is your correct answer for this. So if it's flowing from one or more of the voltage carrying wires and it's going directly to ground, then that GFI is going to trip. Why must the metal enclosure of every item of station equipment be grounded? You know, think about touching that chassis in this case. It ensures that hazardous voltages cannot appear on the chassis. Which wire or wires in a four conductor connection should be attached to fuses or a circuit breaker in a device operated from a 240 volt AC single phase source? You don't want to put fuses or breakers on your neutral and ground wires, only your two wires carrying voltage, and they can be red, typically red and black wires. Which size of fuse or circuit breaker would be appropriate to use with a circuit that uses AWG number 14 wire? Okay, 14, 15. You remember that F, 14, 15. So 15 amps is an appropriate circuit breaker or fuse value. The minimum wire size that may be safely used for a circuit that draws up to 20 amperes of continuous current. Again, we have that 2012 thing going on, so it's AWG number 12, 2012. What is the purpose of a transmitter power supply interlock? Again, if you open up that cabinet, the door, or whatever, it's to make sure that those dangerous voltages that are present inside the cabinet are disconnected if the cabinet is opened or removed. So that's what your power supply interlock switch does. Prevents you from being shocked and turned into fried bacon. Which of the following is a danger from lead tin solder? Lead tin solder can be very toxic, so you really want to make sure that uh, after handling your lead tin solder or anything that contains lead, you don't want to contaminate your food and you want to wash your hands thoroughly after handling the solder. Which of the following is a good practice for lightning protection grounds? Okay, again, when you ground those things, they have to be all bonded together with all the other grounds. That'll also help prevent ground loops, which can be a whole nother issue. Why should soldered joints not be used with wires that connect the base of a tower to a system of ground rods? Soldered joints uh, predominantly have the propensity to be very weak. But more so, if you get a lightning strike, that solder joint can likely be destroyed by the heat of a lightning strike. So that ground automatically becomes no good. So you don't want to use soldered joints for that. Which of the following is a primary reason for not placing a gasoline fueled generator inside an occupied area? Again, it's that danger of carbon monoxide. You don't want to breathe that in. You don't want to have it inside your garage, your basement or any, any place that you're going to occupy or any human is going to occupy. It needs to be outside and, in a well ventilated area away from people, basically. What must you do when powering your house from an emergency generator? Ag- Very important. You do not want to backfeed to the public grid, so you want to disconnect the incoming utility power feed to the public grid. That's turning off the main breaker at your main panel in your house. Which of the following is true of an emergency generator installation? We look at this. Generator should be located in a well ventilated area. And that is predominantly the true statement here. Really, the generator should not be um, insulated from the ground. It needs to be grounded as well. So, really, A is the only answer here. The generator should be located in a well ventilated area. So, with that, this is the end. Hooray, you have finished the book. Look at some of the helpful pages that are in there in your appendix and the pictures, some of the charts. Leverage some of the resources you can find on the web. And if you're not sure about terminology, again, you have the World Wide Web available to you. And you also have me that you can field questions to if you'd like. And I'll do my best to help you. Definitely. I hope you've had some good success and you get your general class ticket upgrading from tech class. And if you did get something out of this series of YouTube videos based on Gordon West's W5YI uh, General Class License Manual, drop me a note, send it to Wayne at n3lms.net. You can also drop into my website at n3lms.net. Leave me a message there. But I've enjoyed doing this. I'm sorry for the technical problems that we may have had along the way, and I hope I wasn't too monotonous. Um, by the end of the day here, I'm kind of tired. I want to thank everybody who joined me in this, both live and even after the fact. So with that, I'm going to go ahead and I'm going to drop this broadcast, and we're going to wrap this YouTube series up. I wish everybody success. Wish you all the best in getting your license. And perhaps maybe you'll also pursue getting upgraded to extra class license uh, status. And by going extra class, you get portions of the bands opened up to you where most of the DX stations are. If your thing is trying to contact DX stations, that's probably where you want to be, is in the extra class license status. All right, everybody take care and blessings to everybody. It's been fun.